x cubed, we have 3, and we have 2, then x squared. We have also 3 as this coefficient. We have x, we have 2 squared. The next one, we have 2 to the power of 3. Is that one okay? Using binomial expansion. Then you expand, we have x cubed. Here we have 6x squared. Here we have 4 times 3, we have 12x. And we have 2 power 3, which is 8. So the value of our y is this now. So we have y equals to this. Change in y will be y plus dy, which is equals to, here change in this x, we have x plus the x cubed, plus 6. Change in this x squared, we have x plus the x squared, plus 12. Here we have x plus the x. Then we have plus 8. So the same thing here, we have y plus dy. We need more space. From there we have y plus dy is equals to, we need to expand this. It's to the power of 3. We'll apply binomial expansion and expand this to have x cubed. Still is power of 3. We are going to have this as the coefficient. We'll have 3 x squared dx plus 3x dx squared plus the x cubed. Plus this one we have 6. We need to expand this x plus the x squared to have what? X squared plus 2x dx plus what? The x squared. Plus I expand this to have 12x plus 12 dx plus 8. Then I can take this y to right hand side to have dy is nothing but x cubed plus 3x squared dx plus 3x dx squared plus the s cubed, plus I expand this to have 6x squared plus 12x dx plus what? 6 dx squared plus 12x plus 12 dx plus 8 minus our y. What is our y? We have our y is minus s cubed. We can take it direct. Our y is s cubed to be minus s cubed minus 6x squared minus 12x minus 8. From there, this guy will cancel this guy. This guy also 6x squared. We also have what again? This 8 will go with this 8. 12x will go with this 12x. We will have dy is equals to 3x squared dx plus 3x dx squared plus the x cubed plus 12x dx plus 6 dx squared plus 12 dx. Any other thing? So from here we divide through by the x to have dy over the x is equals to, this one will go, we have 3x squared plus this one will change to the x, 3x dx plus this one will change to the x squared. We have the x squared. This one will change to what? 12x plus 6 the x, right? Plus 12. From here, we apply the limits from the Leibniz notation that lim dy over the x at x tends to 0, the x tends to 0 of all this function. So we'll have we apply limit at the x change to 0 here. This one will change to 0 because of this the x. This one we have the x square will also tend to 0. Here there is no the x. This one here there is the x, it will also change to 0. So we'll have dy over the x is equals to, we have 3x squared. This one will change to 0, this one 0, we have 12x plus 12. If you like, you can factor 3 to have this plus 4x plus 4, right? So you have 3. This one is the same thing as x plus 2x plus 2, which is x plus 2 square. If you expand this x plus 2 square, you will have this x square plus 4x plus 4. So this is derivative of y equals to x plus 2 to the power of 3. So even this example, using chain rule, you can find it in 10 seconds. But using test principle, it takes more time. So I think we are going to stop here for differentiation using test principle. All other examples, you can go through them and you can further your studies with textbooks, internet, YouTube, and others.